All right, guys, this is example 7 in section 7.5. Yay, it's the last one, okay? All right, so, all right, why not start with my toddler jokes, right? Let's see. Why did Mickey Mouse go to outer space? Why did Mickey Mouse go to outer space? He was looking for Pluto. If you don't know, Pluto is his dog. Okay, so here we go, example 7. Solve each on the interval of 0 to 2 pi inclusive. Okay, so keep that in mind because it's including 0 and 2 pi can have both. Your book, though, might have a different set of directions, okay? If it says like solve from 0 to 2 pi, not including 2 pi, then you can't have 2 pi. Let's review a little bit from Algebra 1. Review Algebra 1, okay? What if I said, let's say, what can I have? Let's give you this. X squared equals 9. What is x? X squared equals 9. What's x? Okay, most of you said, okay, well, I would take the square root. That's correct. And most of you said x equals 3. Well, that's partially correct. Okay, because technically, couldn't x also be negative 3? Okay, so you should have both, okay? And that's why we have, anytime you take a square root, there are 2 of them. Now, what if I said, what if this is the true statement, okay? What if x is 3, okay? This is my original question, okay? So because x is 3, would you agree that I can't do anything because that's the only question that can have? But what if I go in and square both sides? Okay. Then would you agree that this is x squared equals 9? Okay. That is true, right? It's true and true. Okay. But here's my question. And I said, well, from here, I would like for you to solve. Okay. Well, when you take a square root, you take a square root. X comes back down to, well, you take a square root. There are 2 of them. But what's wrong with this answer? What's wrong with this answer? Remember, the original question is not square, right? So when you square it and you went back and solve for it, see there's an extra answer? Extra answer because you square it, okay? So I want you to look at this, okay? This is a true statement. This is a true statement, okay? But when I solve for this, see this right here? I ended up with 2 answers, but my original statement was only 1. So in algebra, we are manipulating equations so we can solve. Like we borrow things, we manipulate things, okay? We substitute with an identity so we can solve. But when you solve, don't forget to check the answers, okay? So let's keep that in mind. Don't forget to check the answers. So let me spell that out. Check answers, okay? Here we go. So our first equation is quantity sine of theta plus cosine of theta, all of it squared, equals 1. Most of us would write this out twice, right? Most of us would write this out twice and then multiply. Of course, you can do that. There's nothing wrong with that. Okay, so here we go. Equals 1. Okay, let's FOIL cautiously. Sine times sine is sine squared of theta. Sine times cosine is sine times cosine, because there's not much I can do with that. And then in the middle, there's another one, sine times cosine. And then cosine times cosine is going to be cosine squared of theta. And then equals to 1. Okay, well, look. Okay, I can put those together and I can add these together. So now I have sine squared of theta plus cosine squared of theta. In the middle, I have 2 sine cosine. Okay, equals 1. Well, this is an identity. I can substitute that. So here we are. Okay, I'm gonna see if I can move the 1s. Oh, so when I move the 1, okay, I now have 2 times sine of theta cosine of theta equals 0. Okay, Well, this is like a factor. See that right there? So I can take each factor and set it equals to 0 because it's, okay, perfect. Okay, so now divide both sides by 2. Well, 0 divided by 2 is 0, so cosine of theta equals 0. Cosine of 0 is here and here, so that's pi over 2 and 3 pi over 2, okay? Oops, I'm sorry, that's 2 sine of theta. My bad. Change that. So that means my answer is going to be different here. Sorry, I jumped the gun. The cosine's on the other side. Okay, so this is 2 sine of theta. 2 sine of theta equals 0. 0 divided by 2 is 0. So sine of 0 is here and here. So that means it's 0, pi, and because 2 pi is included in this restriction, I have to write 2 pi. Now cosine of 0 is here, which I did this earlier. That's sort of pi over 2 and 3 pi over 2. So would you agree, it looks like we have 5 answers, right? Theta is, let's start from small to big, 0, pi over 2, pi, 3 pi over 2. And because 2 pi is included in my instruction, I want to write down 2 pi. But the question is, can I keep all of this? Okay, so let's go back and check them. So let's start with the first theta, which is 0. Okay, here's check. Okay, so my original question is sine of theta plus cosine of theta, all of this square equals 1. Then my first angle is 0. So sine of 0, oops, I write it like theta, but it's supposed to be 0. Sine of 0 plus cosine of 0, 0 is an angle, square, question mark, equals to 1. Well, sine of 0, here's 0, sine of 0 is 0. So 0 plus 1, everything square equals 1. Checked, I can keep 0. How about pi over 2? Okay, and then we go, hey, sine of pi over 2 plus cosine of pi over 2, everything square equals question mark 1. Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1. 1 square is 1. Check, I can keep that. How about pi? Sine of pi plus cosine of pi, everything square equals question mark 1. Well, sine of pi is 0, so that goes away. Cosine of pi is negative 1. Remember, everything's square. So check, I can keep that. So what's going on? Looks like I can keep all 5 answers because the deal is that this is being square right here. You see this right here? And anytime that you have anything being square, all the negative will become positive. So that's why I can keep all of these. All of that is my answer. Okay. Okay. So don't forget to check. Okay. So let's do example B. Example B, we will use a different ink here. Now, please don't be mistaken that this is not 1, okay? Not 1. So the only time that you can change that into 1 is when it's sine square of theta plus cosine square of theta. This is 1, okay? All right, so how would I solve that? What would you do? Right now, honestly, there's not much you can do. So the first step is I'm going to square both sides. Like that, okay? If I square the right, I can square the left, and yes, that still be equal. So since I square both sides, this is what I now have. Wow! Doesn't that look like, looks like part A after squaring both sides? Yes, it is. Okay, so it does. So let's start solving. Well, but if it looks like part A, couldn't I just use the same answer as part A? Yes, you can. You can have the same solutions at the bottom like part A. But you know what? Since this is notes, let me teach you another way of solving. So let's use purple, okay? In part A, I solve for it by multiplying it out. But what if I want to solve for it by doing this? Okay, taking the square root. Is that okay to do? Well, some of you would totally start that way, right? Okay, well, let's try. If I take this square root, I now have sine of theta plus cosine of theta equals positive and negative 1. Then I'm going to go like this. You know, teacher, I would write it out like this and set this equal to 1 and write it out like this and set this equal to negative 1. Is that okay to do? Please don't do that, okay? That only works if it equals to 0 and you have factors. So please don't do that ever, okay? So as you can see, what happens when you take the square root? You are back to the original, okay? So keep in mind, the only way to solve for it is really multiplying it out, okay? Your identity all have squares. So when you multiply it out, okay, then they become square terms and you can use your identity. So keep in mind, you may not do this ever, okay, unless it equals to 0. Now, let me talk to you about what to do next, okay? So we solve for it the same way. Solve for it the same way as part A, okay? When you solve for it for the same way, you have theta equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. But keep in mind your original equation, okay? Original equation was sine of theta plus cosine of theta equals 1. We square both sides so that way we can manipulate the equation to solve, but that's not the original. When you check, you need to go back to the original, okay? So check. When sine is 0, so let's plug in sine of 0 plus cosine of 0, is it question mark equal to 1? Well, sine of 0 is 0, so that goes away. Cosine of 0 is 1, so 1 equals 1. Check, I can keep that one. How about when is a pi over 2? Sine of pi over 2 is 1 plus cosine of pi over 2 equals question mark, is it 1? Well, cosine of pi over 2 is 0. Sine of pi over 2 is 1, so that it's okay. How about pi? Sine of pi plus cosine of pi equals question mark 1. Sine of pi is 0, so that's okay. Cosine of pi is negative 1. Negative 1 does not equal to 1, so I can't keep that. So you see the difference between A and B? So, and then how about 3 pi over 2? Kind of the same thing, right? So sine of 3 pi over 2 plus cosine of 3 pi over 2, question mark, is it 1? Well, cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is negative 1. Negative 1 does not equal to 1, okay? So that doesn't work. How about 2 pi? Okay, so sine of 2 pi plus cosine of 2 pi equals question mark 1. Well, this will work because cosine 2 pi is positive 1. So this one, part A, has all 5 answers. What gets going on with part B? There are only 3, 0, pi over 2, and 2 pi, and these are the only ones that you can keep. So let's see the difference, right? The difference that in part A, we didn't have to square both sides. So that's why there were no extra answers. But in part B, we had to square both sides so we can manipulate the identities to solve. So when you square both sides, let's go back to this thing right here, right? When you square both sides, what's going on? You have extra answers. So the rule of thumb is when you square both sides, you should always check your solutions, okay? So when squaring both sides to solve, check final set of solutions because you have created extras, okay? Because you square both sides, now you have created extras. That means you need to test which one of the extra ones that don't belong in the original, okay? All right, so this is the end of our 7.5, yay!